Imagine yourself living in a bubble, surrounded by your protective shield, shielding you from the outside detrimental agents of the outside world, of the outside space. Well, this is the Earth's atmosphere.
I don't really know what comes next.
Welcome back on the SpaceInfo podcast. Here we talk about space and everything related to it. If you are passionate about space, astronomy, technology and everything about it, you can join all our social platforms at the SpaceInfo Club or our website at www.spaceinfo.club, where tons of content and a community of experts are there waiting for you. This is the SpaceInfo Club. So first of all, thanks to all the people that reached out to us via our social channels, and also some of you also wrote us via the spaceinfo.club website. And after the latest video talking with the European Space Agency Gabriele Meoni about artificial intelligence and Earth observation, a lot of you reached out and would like us to talk more about Earth atmosphere and our planet in general. So I'd like to start a new series today by starting talking about our planet, and in particular the atmosphere of our planet. We'll talk about Earth's atmosphere and its layers in a very simple way, without giving you much formulas, mathematical concepts, or any number of sort. And we'll start talking in a very generic way about the atmosphere. So let me know if you appreciate this kind of content, very oriented to your requests, or if you'd like to have more significant numbers, some more mathematical formulas or things like that, or maybe you want both kind of content. Just let me know in the comment, because today we start talking about Earth's atmosphere, which is a vital layer of gases that surrounds our planet. Basically it moves together with our planet, so you don't have to imagine as a layer which is independent with respect to Earth, but since Earth is rotating, and yes, Earth can be approximated as a sphere, and it's not flat for sure. So I'm sorry for the flat earthers out there listening to the podcast, you can just close the video now. And yeah, so the atmosphere is drafted together with the planet, and it's moving. It has also minor and micro movements inside the whole atmosphere, which can be said as local movements together with an overall movement associated with the rotation of our planet. So basically what makes this thin layer of gases so special is that it provides air and protects from solar radiation, and also regulates the temperature. So basically it gives us oxygen for the respiration and carbon dioxide for the photosynthesis of plants, basically, which are both essential for life. And also it acts as a shield by absorbing the so-called radiation, UV ultraviolet radiation from the sun and X-rays. Well, it doesn't absorb, this is a sort of spoiler for you, all the radiation coming from outside our planet, and I'm also referring to cosmic radiation, galactic cosmic rays. We have talking about this particular topic in previous videos about the Polaris Dawn program and the Polaris Dawn mission, where astronauts were exposed to a particular dose of radiation, where also the astronauts living on the International Space Station don't experience. Well, but this is the matter of another video, just inviting you to give a look to it. So also the Earth's atmosphere moderates the climate on a planet, preventing extreme heat during the day and also cold at night. So it makes basically the whole planet favorable to life as we know it. Indeed, we are not we don't know any life on the moon, for example. Even though there is no liquid water, there is water ice, but there is no atmosphere, basically due to the very low gravity, which doesn't allow to be compatibly with the escape velocity of molecula, doesn't allow the formation of an atmosphere. But this is again a matter for another video, but this is basically the explanation why on the moon there is no atmosphere, and you also experience a very high gradient of temperature between the maximum during the lunar day and the minimum during the lunar night, which can vary from plus 120 150 degrees centigrade Celsius and minus 100 and 150 degrees Celsius. So an overall gradient of temperature of something like between 2 and 300 degrees. So well, this is not the best case, the best thing for life for sure, but what's the composition? So what are we breathing basically within our atmosphere? Well, as we'll see, the concentration of these gases, which I'm going to measure now, varies a lot with also the altitude with respect to Earth's surface basically. But let's say at sea level we have 78% of nitrogen and 21% of oxygen, which is basically the only useful gas for our respiration. So there are also other gases like argon 0.93%, carbon dioxide in a very small percentage 0.04%, and also variable amounts of water vapor, for example, contributing to processes like climate regulation and the weather basically. So depending on, again, as I said at the beginning, to local phenomena and also local weather, the percentages particular of water vapor, which disappears with altitude, is a variable characteristic of the atmosphere itself, depending on the let's say spot on our planet and also on the altitude. Basically, water vapor is the fastest disappearing gas, even though it's not properly a gas, but again is a vapor, as said, which disappears very fast with the changing, with increasing of altitude, while other gases, as we'll see, like oxygen, molecular oxygen, is more dissociated into atomic oxygen thanks to the radiation. But we're going to talk about this in a very few seconds, because now we start talking about the first layer, which is the one where we live in, which is called the troposphere. Well, the troposphere extends from 0 kilometers, basically from sea level, up to 8 to 15 kilometers. So you may wonder why there is such a wide range of let's say altitude from the surface where the troposphere can be defined. Well, you don't have to forget that the whole atmosphere itself, so from the very low, from the very sea level basically up to the let's say farthest layer, which is the exosphere, where they are all sort of breathing. So you don't have to think about as the atmosphere and basically the whole planet and also the whole dynamics of life basically as a static thing, but again as a dynamic phenomenon. So also the atmosphere is a dynamic phenomenon, and so it varies depending on weather conditions, and in particular from the conditions coming from outside of our planet. One of the most influential condition is the sun activity, which makes the whole atmosphere vary a lot. And you have to imagine the atmosphere as a breathing organism. So it will be higher or lower. It will move also with respect to altitude, so with respect to the surface of our planet, depending on what's happening by the external phenomenon. So you have this very wide range of let's say altitude of the troposphere, whose border is called tropopause. So again, the troposphere is the lowest layer, and also it is thickest at the equator and thinner at the poles. So this makes you think about Van Allen belts and also electromagnetic phenomena we have already talked about in previous videos. And if you want us to talk more deep into this kind of phenomenon more specifically, just let me know in the comments and I will make a video particularly about electromagnetic phenomenon and things like that on our planet. Again, also weather phenomena including clouds, rain, storms, for example, occur here in the troposphere due to the presence of water vapor and also aerosols. Do you remember what I've said in the beginning? Well, this is exactly the place where this kind of phenomena happen. Also, as altitude increases, the temperature decreases in this specific layer, which is why mountaintops are much colder than the valleys, for example. This is a very empirical, intuitive phenomenon you can observe by yourself. So, also the life on Earth, including us as humans, are within the troposphere. And again, between the troposphere and the next layer, there is the tropopause, which is basically an ideal border separating the two layers. The second of which is the stratosphere, which is kind of theoretically defined between 15 and 50 kilometers and houses the ozone layer, which absorbs the harmful ultraviolet radiation coming from the sun. You're for sure familiar with the ozone layer, which is a molecule made up by 3 atoms of oxygen. And again, what I'm saying at the beginning, oxygen doesn't really disappear with the increasing of altitude, but basically changes its let's say form by being dissociated at the highest altitude, but also be chemically interacting with other molecules of oxygen. And when you give it enough energy, you can change from molecular oxygen, which is basically made up of 2 atoms of oxygen, up to a molecule which is the ozone, made up of 3 atoms of oxygen. So it also acts as a protective layer, in particular from some harmful UV rays, which are ultraviolet rays, and also protect us who are the living organism more in general from being damaged, in particularly from our DNA being damaged, and also skin cancer, for example. This is the most effective and the most useful protective, let's say, feature of the ozone layer. That's why it is important. So also, differently from the troposphere, the temperature here in the stratosphere increases with altitude. So the farther you get from the surface, the higher the temperature will be. So in the stratosphere, due to the absorption of solar radiation by the ozone molecule, you can increase the thermal agitation of these molecules themselves, and therefore by definition of temperature and by empirical measuring it, the temperatures will increase with altitude. And then the stratosphere is also important for aviation. Indeed, many commercial jets fly in the lower, let's say, sublayer of the stratosphere. So you can imagine that it goes from 15 to 50 kilometers. You can think that most of the commercial, intercontinental, and jets in general fly between 11 and 25 kilometers from the surface. So basically you can think as the stratosphere and the lowest part of the stratosphere as the main layer where commercial aviation fly. So then at 50 kilometers you can encounter again the stratopause, which is the border between the stratosphere and the next one, which is the mesosphere. So this is basically the coolest layer, which extends from 50 to 85 kilometers, approximately from 30 to 55 miles from the surface for our US friends. So this layer basically experiences the coldest temperature in the atmosphere, as low as minus 90 degrees centigrade, like minus 130 Fahrenheit, and this is one of the coldest layer in the atmosphere, and also where most of the meteors coming from outside of the planet basically burn up. Again, I'm talking about meteors and not meteorite. If you want to know the difference, I've realized already a video on the channel, and if it wasn't enough clear, just let me know in the comment and I will make another one with more clear and more detailed information for sure. So also, due to the difficulty of accessing the mesosphere with aircraft or balloons, basically because all the aircraft or all the flying vehicles apart from rockets are air-breathing vehicles. And again, I've talked about this in the rocketry course, but I can make a video, just let me know What are air-breathing vehicles? Are all the vehicles that, for example, jets, so reaction vehicles or reaction engines, which need, yes, the fuel on one side, but also the oxidant, which is basically the oxygen of the atmosphere. Only rockets are the vehicles, the flying vehicles, which brings both there's, let's say, ingredient for propulsion on board, and then basically they are stored in tanks on board, and then they use them for the propulsion. But if you are on board of an helicopter and then also a jet or flying things like that, you only have fuel on board, and the oxidant comes from the outside atmosphere. But since the air, basically the atmosphere, is so rarefied, you don't have enough oxidant on the surroundings, so you cannot fly. Basically, you have both a propulsive and also aerodynamic limitation on your vehicle. And then again, if we go farther from the surface, we start encountering the thermosphere. Again, this goes from 85 to 600 kilometers. And also, yes, the image you are seeing now is what makes you think about this kind of layer. So this is basically the home for auroras and also satellites. It experiences extremely high temperatures and also again hosts the majority of satellites and spacecraft. We can already talk about spacecraft. Indeed, we are above the theoretical border between the ordinary atmosphere and space, which is defined by the Kármán line, which is again theoretically established at 100 kilometers from the surface. Again, this is I underline this because it is a theoretical border. So temperatures in the thermosphere can reach up to 2500 degrees Celsius, which is far more than 4500 Fahrenheit on the other scale. So due to the low density of the particles, the heat cannot be felt in the same way as on Earth's surface. So basically, if a human could stand, let's say, naked, with naked skin in this kind of environment, it is for sure impossible. Your blood would start boil and you would die instantly. But let's experience the sensation of the heat on your skin, on your body. Well, for sure, this kind of sensation would be kind of completely different from what you're going to experience here on the surface. Indeed, the atmosphere is so rarefied that all the convective phenomena, so the air blending your skin, for example, would be basically absent. So the only kind of radiation would be the only kind of heat you're going to experience is the radiative heat coming from the sun, basically. Yes, some percentage of the heat will come also from the albedo and the reflection of the Earth's, which is for sure not neglectable, but the majority of that heat will come from the sun radiation. So this is a very peculiar characteristic that people who are designing spacecraft are for sure going to take into account when designing and thinking about flying things. And for sure, people who designed the International Space Station and all the other satellites flying in this kind of layer have for sure thought about, because this is a fundamental thing to think about when designing spacecraft. Also, auroras, northern and southern lights occur in this layer when the charged particles from the sun basically collide with the Earth's magnetic field. Well, this is a very, let's say, simplistic, very simple explanation. We could go deeper into detail, but as I said, this is a generic explanation, is a generic exposure of the Earth's atmosphere. Just let me know if you want more details, and I will make a video. Again, that's for sure very open to your desire. Just let me know in the comment. So, also, as said, the International Space Station orbits in this layer, something like 400 kilometers around Earth. So, and also very other satellites, because this is what's defined as LEO, so low Earth orbit. If we go farther from the surface again, we encounter the exosphere, which extends up to 10,000 kilometers from the surface. This is called the boundary with space. because basically well, it is said up to 10,000 kilometers, because maybe you have heard about let's say the borders of the solar system. Also here we don't have a very precise border, but we are defining we can define the exosphere and the border between deep space, again just staying in the solar system, as let's say a theoretical limit where, for example, the density is lower than some kind of number or some kind of parameter, just to define and say in the theoretical models, okay, this is the end of the exosphere, but this is very theoretical. So the exosphere is also the outermost layer of the atmosphere, so starts from 600 kilometers from the previous layer, which is the thermosphere, and reaches something like 10,000 kilometers. This is more of let's say a model, theoretical model. So also contains very few particles, which are mostly hydrogen and also helium, so the first two elements of the periodic table. And also they are so sparse, they are so rare that they can travel great distances without colliding with each other. So this can be, for example, a parameter, a measure of the border of the exosphere, distinguishing it with deep space. So you can, let's say, just without going too much into theoretical things, you can define the mean walk of particles between colliding with each other. So you can say, okay, if one particle can travel 1 meter, 10 meters, 1 kilometer, just to give you an idea, between colliding with another particle of whichever nature, well, okay, so if you are above this distance of collision, which can be also said as a frequency of collision, well, for sure you are outside of the exosphere or you are inside. This can be a parameter to be defined. Also, the exosphere gradually transitions from the vacuum of outer space with no clear boundary separating Earth atmosphere from space. This is basically the summary of what we are saying now. Also, a lot of satellites are also orbiting in this region, which is very favorable due to the very low atmospheric drag. You only have SRP, so solar radiation pressure, and other perturbations like the gravitational ones, for example, but the atmospheric drag is very low. This is a sort of an intermediate, let's say, slot, an intermediate group of orbits between low Earth orbit and also geostationary orbit, which are something like 36,000 kilometers from the surface. Again, but why is atmosphere so important? This is the topic of today, without losing the concentration of the atmosphere. Maybe you're going to say, okay, now I understand how it's made, so which is the composition of the atmosphere and which are its layers, but why it is so important? Well, there are many reasons, but for sure a few of them, which are the most important, can be said. So as we've said in the beginning, one of them is that the atmosphere is a protective shield, because the ozone layer in the stratosphere protects us from the ultraviolet radiation, which can cause, for example, skin cancer and genetic damage. Just to give you a more generic idea, the stratosphere is where the ozone is hosted, and the ozone is altered, is chemically modified into molecular oxygen and also atomic oxygen, so basically dividing the three oxygens of the ozone molecule into smaller parts, which can be atoms or molecular oxygen, thanks to the external energy coming from the sun. But this energy is indeed the ultraviolet radiation. So you can imagine that this radiation can basically break apart the ozone molecule, and it will also make a very similar effect on our skin. And this is the reason why skin cancer is caused basically on living organisms, in particular humans. Also, X-rays and gamma rays coming from space are absorbed in the upper layers, so the thermosphere of the whole atmosphere, shielding Earth basically from this kind of radiation. I would say that only, let's say, the least energetic ones, which are, by the way, the most frequent ones. So this is again a very effective protective shield from outer space. Also, the atmosphere burns up the meteors, so the smallest rocky bodies coming from space, which for sure will not reach Earth's surface, basically falling on our heads, basically. So this is one of the reasons why it is important. Another one is the greenhouse effect. Basically, it's our planet's temperature regulator. Indeed, is the process by which certain gases in the atmosphere are trapped heat from the sun. So carbon dioxide, the famous CO2 gas, water vapor, and also methane are some of the main greenhouse gases that absorb the heat and prevent it from escaping back to space. Again, as said, why we were talking about the moon, and the reason why it has no atmosphere, well, not about the causes, but the effects of having no atmosphere is that you are experiencing a very high temperature gradient, also from day to night. This is for sure not the most favorable condition for life. The greenhouse effect, let's say in its mildest conception, that's kind of the way we can think about it, for sure is favorable to life, because it basically makes milder the thermal condition of the planet. So this effect is essential for maintaining a stable climate on the planet. Also, it keeps the average global temperature around 15 degrees. So without the greenhouse effect, basically Earth would be too cold for life. So in this sense, it is for sure a positive effect for the life on our planet. What's not positive is the fact that human activities are burning fossil fuels, for example, and so increasing the greenhouse gases basically intensifies the greenhouse effect, and so the mean temperature on the overall planet is increasing, and this is not positive. So as a lot of things in nature, they are good if you can exploit them, you can use in some kind of way in their best conditions. But if you exaggerate, in this case, the greenhouse effect, you will have a global warming of the whole planet, and so basically this is not positive for sure. So, but we are not going to talk about this in this video. And the last one of the most positive effect of the planet is about water cycle. So basically the atmosphere is integral to the functioning of Earth's water cycle and also the ecosystem, because water vapor in the atmosphere condenses and form clouds, which then release precipitation, rain, snow, and things like that, which are essential for the water cycles and sustaining life. So this also allows the movements of great and gigantic water masses also along the whole planet, and also the movement of air currents like distributes also the seeds and the pollen and also the nutrients, and this is a great support of life and also basically the procreation of life, things like that. Also the atmosphere, also as I was saying at the beginning about air breathing engines, the atmosphere enables aviation and also global transportation. Indeed, airplanes only rely on air pressure and also air temperature and air density and things like that to generate lift and also move in the atmosphere. Also, space exploration is important, but rockets must pass through the atmosphere to reach space, and that's where satellites remain in the upper layer to perform tasks like communication and also weather forecasting. So this is basically the last important thing of our atmosphere. Now, I hope that you enjoyed the video, and I hope that you find it interesting. I've tried to condensate a lot of things in the smallest video possible. Let me know in the comments if you like this kind of format, if you like this new series about our planet, and let me know what you'd like to see next time. See you in the next video.